Hello and welcome. I hope you're all well. This is Rashid Khan and you're watching my YouTube channel. In this video, I'll go through some of the exam questions on the topic called particle model. The first question says, on a very cold day, the temperature of the air is -4 degrees Celsius. Calculate the value of this temperature on the Kelvin scale. You have to remember there's an equation. Temperature in Kelvin is always equal to temperature in degrees Celsius plus 273. You have to memorize this equation, and if you just plug in the values, we've been asked to work out this value. We've been given this value as -4, 273 will stay as it is. If you add the two numbers together, it will give you answer as plus 269. Okay, next question says, describe what happens when a substance experiences sublimation. So the moment I see this word sublimation, I have to recall myself. This is about state change. So we'll say state change when solid directly goes into gas. Next question. Figure 1 shows some gas in a container. So we've been given some gas here and it's in a container. It says the pressure of the gas in figure 1 is 103 kPa. That's the pressure in this container. And the volume is 0.010 meter cube. Calculate the pressure of the gas if the volume is now 0.0070. This is the final volume. So I can say this is V start, this is V final, this is P start, this is calculate the pressure, this is P final. Now we've been given equation, we know one equation, and says use an equation selected from the list of equations. So the equation is P1 times P1 equals P2 times V2. Now P1 will be the start state, V1 will be the volume at the start state, 2 represents the final. So in this case, you have to remember units must be same on both sides. Any questions like that, you will have to keep this in mind. It was the same concept when you were doing clockwise moments equals anti-clockwise moments. So P1 value is given to us as 103. V1 value is given to us as 0.010. P2 value is not known. I'll keep it as P2. V2 value, which is final, is 0.007. Once I've done this, all I have to do is divide both sides by 0.007. 0.007. This cancels out, and I'm left with P2 on the right side. On the left side, if you put it in your calculator, you'll end up with an answer, and that will be in kPa. It will be in kPa because we used our pressure in kPa on the left side. Next question. A student uses the apparatus in figure 3 to determine the specific heat capacity of water. So he's trying to determine the specific heat capacity of water. Remind yourself, there's an equation for specific heat capacity, and that is energy supplied is equal to M times C times change in temperature, where I can rewrite it as M times C times T final, take away, T start. It says state the measurements needed to calculate the specific heat capacity of water. So calculate means this is not known, and rest of the things will need to be measured. So I can say this will come from this joule meter. So I can say energy supplied from joule meter. Number 2, I will need a value of mass. To get the value of mass, I will use balance. So I can say measure mass of water using balance. I need 2 more values, the starting value of the temperature and the final value of the temperature. I can then say measure starting and final temperature using thermometer. And then I can say to work out delta T, it will be T final, take away T star. And that will get me full marks in this case. Next part says state 2 ways that the apparatus could be adapted to improve the procedure. Now the main thing that you have to remember in this case is we are assuming that all energy is transferred to water. But this will not be the case in reality due to two reasons. Number one is there's no lid on the cup. Number two, this immersion heater might not be fully in water. We can write down those two recommendations. We can say put lid on the cup. Number two, I can say ensure immersion heater is fully submerged. We can also think about one more thing here, and that is we are recording the temperature. So if you keep your thermometer more close to the immersion heater, you'll record a bigger value. If you keep it further, you will record a smaller value. To avoid that, what we need to do is we will have to mix water continuously before we take the reading. We can say 3, use stirrer to ensure correct value of temperature. Is recorded. Next question says figure 2 shows a rubber tube that can be used inside a bicycle tire. The tube is inflated with a bicycle pump. So before it is like this, once it is inflated, it appears like that. The air inside the tube exerts an outward force on the wall of the tube. State the angle that this outward force makes with the wall of the tube. You have to recall they're talking about pressure. Pressure is equals to force over area. That's another equation. You have to remember force and area are at 90 degrees to each other. In this case, my answer will be 90 degrees. Next part says it takes 4.8 liters of air from the atmosphere. From the atmosphere means this is my location 1. So this will be my V1. To inflate the empty tube to a pressure of 400,000 pascals. To a pressure of, this means this is my final pressure, so I'll call it P2. The atmospheric pressure is 100,000 kPa. Atmospheric pressure means this is the pressure outside the tube, so this will be my P1. Calculate the volume of air inside the tube. This means V2 is not known. The question further says, assume the temperature of the air inside the tube is same as the temperature of the air outside the tube. Use an equation selected from the list of equations at the end of the paper. So again, same equation, P1 times V1 equals P2 times V2. Now P1 has a value here, which is 100,000. V1 has a value which is 4.8. P2 has a value which is 400,000. And we do not know the value of V2. All I have to do is to make V2 my subject, I'll divide both sides by 400,000. So cancel out. If you plug this value in your calculator, it will give you an answer for V2 and it will be in liters because our volume in this case was in liters. Remember, whenever you use this equation, units must be same on both sides. So pressure should have same unit on both sides. Volume should have same unit on both sides. You don't need to do any conversion in that case. Next part, when a bicycle pump is used to inflate the tube, the air in the bicycle pump gets warm. You should ignore any effects of friction in the pump. Explain why the air in the bicycle pump gets warm. So the temperature of the air has gone up. If you remember in my notes, I did show it to you. Basically talking about this section here, work done on the gas. So all you have to say is work is done on the gas because it is being compressed. When work is done on something, the energy state will increase. We can say the internal energy, which is our KE of particles, increases. This causes temperature to go higher. Before I discuss the next question, I would like to share something important. While I was preparing this worksheet for this video, I came across a number of questions where they asked us to convert centimeter cube into meter cube and occasionally meter cube into centimeter cube as well. Now, this is something I have not discussed in my previous videos, so I would like you to make note of this somewhere and keep it safe, because who knows, a conversion might be required similar to this one in your exam. So when you go from centimeter cube to meter cube, you will divide by 1,000,000. When you go from meter cube to centimeter cube, you will multiply by 1,000,000. In this question, we've been given the value of volume and the value of mass. And the question asks us to work out the value of density. The question further says we have to work out our answer in kilograms per meter cube. So if I look at my mass, it is in grams. So I'll have to convert this into kilograms. I'll have to do 28 divided by 1,000. This is now in kilograms. Similarly, I have to convert centimeter cube into meter cube. So I showed it to you here. I'll have to divide 3.6 by 1,000,000, and that's my answer. Density equals mass over volume. I will then replace mass with the value, which is 28 divided by 1,000. I'll replace volume, which is 3.6 divided by 1,000,000. Now, if you plug it in your calculator, you have to make sure when you're plugging it in your calculator, you do put these brackets around, and it'll give you the value of density in kg per meter cube. Next question says the steel bowl is at room temperature of 20 degrees Celsius. It is then put in a pan of boiling water maintained at 100 degrees Celsius. Calculate how much thermal energy the bowl gains as its temperature increases from 20 to 100. From 20 to 100. So this means this is my final, this is my starting temperature. It then further says specific heat capacity of the steel is 510 joules per kilogram degree Celsius, the value of C. And we've been asked to work out thermal energy. So Q is equal to question mark. So the first thing I'm going to do is I need to put down equation that contains Q and C and these. So I'm going to write down Q equals M times C times T final take away T start. Now, if you look at this question, you will notice there's no value of mass here. But if I go back, the value of mass was given at the start. So any data that is given at the start of the question, it will be valid for all parts of that question. So for this part, I'm still going to use this value, but I'm not going to use it in grams. I have to use it in kilograms. So I'll say Q is not known. I'll keep it 28 divided by 1,000 times by 510 times by T final is 100, take away 20. If you put it the way it is shown to you here in your calculator, you'll end up with a value of Q, and that will be in joules. Last part says the steel bowl is put into a furnace where it melts. Melts means it is a state change. Compare the motion of particles in the steel when they are in solid state with the motion when they are in liquid state. So we have to just look at solid and in liquid state. and we only have to talk about the motion. So when it is solid, I'll say particles vibrate about fixed position. Once the liquid state is achieved, then particles can move freely within liquid. This question says figure 4 shows a small piece of copper about 3 centimeters high. A student wants to determine the density of copper. So they want to determine the density of copper. So we'll write down the formula for density, and density is equal to mass divided by. If you have to determine the density, you'll have to make two measurements, a measurement for mass and a measurement for volume. It says student has a balance to measure the mass of the piece of copper. So mass has already been done. Question says explain how the student could measure the volume of piece of copper. Now we need to determine the volume. So when I was going through the notes on this topic, I told you there are three types of objects that you will come across. One will be regularly shaped solid. The other one will be irregularly shaped solid. And the last one will be the liquid. In this case, we have irregular shape. So we'll use displacement method. So first I'll say fill Eureka can with water. Number 2, I'll then say put solid in water and collect water in measuring cylinder. Number 3, I'll say record volume of water in measuring cylinder. And this will be equal to volume of copper. Next question. The mass of piece of copper is 0.058 kilograms. So this is the value of mass. The volume of piece of copper is 6.5 times 10 to the power of minus 6. This is my volume. It says calculate the density. We do not know the value of density. But before I work out my answer, I have to check what units are required for it. The units required are kilogram centimeter cube. So this means mass has to be used in kilograms, but the volume has to be used in centimeter cube. So I will need to convert this to convert meter cube into centimeter cube. If you go back, I gave you this flow diagram. To convert meter cube into centimeter cube, you'll have to multiply it by a million. So we will say it will be 6.5 times 10 to the power of minus 6 times by million. And if you multiply it by million, it will become 6.5 centimeter cube. Now I can write down the equation for density. Density equals mass over volume. The value of mass is 0.058 and the value of volume will be 6.5. If you divide these two values on your calculator, it will give you the answer in kg per centimeter cube. This is the last question on this worksheet. It says an electric kettle contains 1.41 kilogram of water at 25 degrees Celsius. So this is my mass and this is my T start. The kettle is switched on. After a while, the water reaches boiling point at 100 degrees Celsius. This is my T final. The specific heat capacity of water is 4200 joules per kilogram degree Celsius. This is the value of C. We had a similar question before where all data was given at the start. And I told you any data which is given at the start will apply to the entire question. So make sure you keep that bit in mind. Here it says calculate the amount of thermal energy supplied. This means Q is not known by the kettle. Give your answer to appropriate number of significant figures. You have to use the equation from the equation list. The equation is Q equals M times C times delta T. The value of Q is to be calculated. Value of M is 1.41. The value of specific heat capacity is 4200 times by final temperature is 100. Take away 25. If you plug it in your calculator, you will end up with a value in joules. The answer will be 44,150 joules. Now, here the question says you have to give your answer to appropriate number of significant figures. So in this case, I can see this is 2 significant figure. This is also 2 significant figure. This is 3 significant figure. This is 1 significant figure. In this case, majority of the data is given to 2 significant figures. So we'll give our answer to 2 significant figures. So if I change it to 2 significant figures, it will be 44 and 40 joules. Next question says the kettle is kept switched on and the water continues to boil. Now it is boiled, so this means it is about state change. After a while, the mass of the water in the kettle has decreased to 1.21 kilogram. So from here, we were given some starting mass of 1.41. Now the mass is 1.21. So I can say mass evaporated will be equal to 1.41 take away 1.21, which is 0.20 kg. This is the amount of water that has evaporated or changed state. It says the thermal energy supplied to the water during this time was 450,000 joules. This is the value of Q. It says calculate this. It says calculate the specific latent heat of vaporization. The formula is Q equals M times L. The value of M is 0.20. We do not know the value of L, which is latent heat of vaporization, but we have been given the value of Q as 450,000. I can divide both sides by 0.20, 0.20. This will be gone. We'll give you value of L in joules per kilogram, and that would be your answer. This is the end of this worksheet. I hope you'll find these questions helpful. I wish you all very good luck with your exam prep. Please share the video with your friends so that they can also take advantage of these videos. To stay up to date with the content being published on my channel, I request you to hit the like, follow, and notification bell icon. Thank you.